Okay. Good morning, everyone, and welcome to the second day of Ignite conference. My name is Ron Machoro, and I'm a program manager in the SQL security product team. I'm here with Vladimir Ivanovic, which is a program manager in the performance product team, in the SQL performance product team.
Hi, everyone.
So let me start ask you a few questions. Don't you think you are spending too much time to maintain databases nowadays? Don't you think it's getting much too complex to tune and configure your databases? Shouldn't it be configured itself? And what about data security? Wouldn't it be nice if your SQL database service will help you to secure your data and detect threats? We're here today to show you how Azure SQL Database as a cloud database service helps you to achieve more with your database within minutes, with no changes to your application, and with no need to be an expert in databases. We will cover the most advanced SQL intelligent feature that will allow you as an application developer to achieve more and value the database. Okay, so I will start the session with showing you the demo application to give you a bit context that we will use during this session. So we have created a very simple CRM application which uses Azure SQL Database as its back-end database. So it provides a very basic search capabilities, which actually runs SQL queries on the back-end, which retrieve the customer data. Okay. So what do database customer wants? First, we have the application users, which in the example I just showed you, probably will be the sales team or the support team, which actually wants to get their data fast as possible. They don't care if they are running the queries by the end of the quarters and everybody's running every queries on the database. They simply want their data fast. Second, we have the development team or the IT team, which would like to be able to control the database expenses while they need to scale out the amount of database they have. And last, we have the security guys. In the example, we have a lot of customer-sensitive data. There is a variety of sensitive data. And these security guys want us to make sure, as an app developer, that we secure the data, that we prevent potential cyber attacks on the database. The good news is Azure SQL Database as a cloud database service generates and processes tremendous amount of telemetry for million databases, which allow us in Azure to provide you to learn and profile your application usage and provide you actionable recommendation, which will allow you to make your application run faster, will allow you to control your database expenses, and will allow you to secure your data. In this session, we will cover 3 categories of SQL intelligent features, starting with the performance security intelligent features that allow you to tune your database and configure your database based on your application profile. Moving on to the cost intelligent features, which allow you to control and explore your database expenses. And last is the security intelligent features, which will help you to secure your data and detect anomalous activities on your database. Each part will include live demos and customer testimonials, which allow you to understand that choosing Azure SQL Database can make a major difference for your application and your organization. So now, Vladimir will dive into the performance and the cost intelligent feature.
Thank you, Ron. Hi, everyone. I hope everybody had their morning coffee. So without further ado, we're going to see how Azure SQL Database as your backend helps you maximize your database performance and provide great experience to your customers. First off, let's start with the standard scenario. Our web application has Azure SQL Database as a backend. There is a problem of some kind. Application slows down. Users are unhappy, they call, they complain. Our friend Joe, the developer, gets woken up middle of the night, has to investigate, figure out what the problem is, fix it ASAP. Not a good place to be in. Why are database performance issues so hard to deal with? First off, database performance is critical for end-to-end business success. In the world of online applications, users who are online all the time, 24/7, different parts of the world, your application is very likely being used nonstop. So whenever your application grinds to a halt in a world of Twitter and all of the other online medias, everybody knows instantly. It becomes public in split second. So reputation loss is imminent. And this can mean large losses to the business, perhaps even company going down. Now, performance tuning also needs to be an ongoing process. And in today's world, where application changes are made many times per week, sometimes even many times per day, development teams cannot afford long performance testing process before each and every change to the application, at least in most of the situations. So what happens is, performance management is reactive. Your customer knows that there's a performance problem before you do, gets to call you. Again, not a great situation to be in. And finally, database performance management and troubleshooting requires significant expertise and time to master. And given that most of the database users are developers, not DBAs, and not every team out there has an expert in database performance, not all of the teams have access to the skills required to effectively troubleshoot and tune database performance, and do so in a proactive manner before the customers discover the issues. So how can Azure SQL Database help with this? The first piece of the puzzle is SQL Database Advisor. It's a service that provides tailored performance tuning recommendations for your database. The way it works is the following, as in the diagram. So the system monitors your database usage and collects telemetry. And then tuning models which run in Azure Cloud using advanced machine learning algorithms provide tailored tuning recommendations for your database and publish them, make them available within Azure SQL Database Advisor. Then our friend Joe, the developer, can just pick which recommendations to apply. And this is all really simple and easy. The main points is these recommendations are tailored to each individual database. Our models can learn from running millions of databases in the service and provide customized, tailored experience to each one of our customers. Second, the recommendations are based on actual data, actual usage, and will evolve as your application evolves, or as your user base changes, your data access patterns evolve. Whatever happens, recommendations will be automatically adjusted to reflect the current state of your application, to match what you need now. And these are not the best practice type of recommendations, such as, hey, you should really think of turning feature A, B, and C on. No. This is, you need this index to improve your application performance now. And finally, service will do all the heavy lifting associated with implementing these recommendations. So anybody here who has ever had to implement an index, for example, on a live production system, knows that it actually takes many hours, even days, to implement end-to-end. In this case, you would just apply a recommendation, and service will do all of the associated work for you. It'll baseline the performance before the tuning recommendation was applied. It will then apply the recommendation, take another measurement of the performance, compare the two, provide you with a report. And not only this, but if for whatever reason the impact to your application performance was not as expected or even negative, the service will automatically roll back the recommendations. So essentially, it's a fire and forget. You have your own built-in virtual assistant that will do all the heavy lifting. As a result, the experience is now much better. And most of the performance issues in our applications can be detected proactively and fixed quickly. But it gets even better. So why should our friend Joe, the developer, actually have to watch and monitor for these tuning recommendations all the time? His application needs ongoing tuning, 24/7, 365. And as we know, this is something where machines excel at. Database Advisor and automatic tuning is never tired, never has to go to sleep, to vacation, to go for a beer with its buddies. No. It can monitor your application and apply the tuning recommendations as they are needed with really, really fast reaction speeds. Second, even if our friend Joe was an expert and knew exactly how to tune his application, what happens if he has 10 databases to manage? What if he has 100 or 1,000, as many of our customers do? Essentially, there's a point at which it's not feasible for a human to do this and not cost effective. And again, machines and algorithms scale much better than humans. So automatic performance tuning can scale to thousands of databases easily. And now the final point is, it's not a rogue bot that goes and does what it wants. No, you're in full control, and you have complete logs available. Not only what actions have been done, but exactly the commands that were issued against your database. And why is this useful? First, you can really understand what happened. For example, you can take the T-SQL script, and if you want, you can add it to your version control. Let's say automatic tuning added a new index. I can take the script, and if I have my database schema under source control, I can add the script to it. So our friend Joe now has to set the tuning policies, and he's free to work on his application and spend his time and energy towards making a difference for his business, rather than having to manage the Azure SQL Database instead. So let's see how this actually works in practice. I'll flip to a quick demo in the Azure portal. What you see here is Azure portal, and I have my CRM database for our application pinned to the home page. When I click here, what's going to happen is the database blade or the database view is opened up for me. And I can see the KPIs from a database right at my fingertips. I can see that there's some usage, not too much. But I can also see over here, and I'll zoom it for you, one sec, that Database Advisor has detected opportunities for me to improve performance, and let's go and explore those. This is the Database Advisor interface, and it has essentially two tables. The top table has active recommendations for me to review and apply. And the bottom table is the log of completed tuning actions from a database. Recommendations are sorted in the estimated benefit for my application. So high impact recommendations should be reviewed and applied first. Let's open up this create index recommendation. And now the recommendation details view tells me exactly what I need to know. I'll need 128 megs of space for an index that'll that'll be created against employees table. It'll include 2 columns in index key, and it will have 1 included column. And it's also very easy for me to take a look at the script that will be implemented. It's all available. So now that I've reviewed this, yeah, this probably makes sense for my application. I forgot to do this while performance testing. I want to apply it. One click, hey, this is going to apply the recommended index against your database. And by the way, do you want to turn on automatic tuning? Sure, that sounds like a good idea. What happens is the system has now issued a command to implement this recommendation, and it has moved in the bottom table listed as pending. But not only this, the other create index recommendation has also moved into pending state, and the reason for that is because we enabled automatic tuning. So create index is now on for automatic tuning, and so is drop index. Going forward, as the system detects new opportunities for me to improve my performance, it'll automatically not only publish those, but implement them for me. The implementation process can take some time. Typically, it's all done within 1 day. But since we don't have that much time to wait, here, I'm going to show you one of the completed indexes. And here, we can see that the recommendation has been successfully applied and validated. And this one index recommendation has saved 31.75% of my DTU and has improved the performance for 12 particular queries. And not only this, but for these queries, 90% of resources they were using are now saved. So you've seen how easy and simple this was. All it took for me was a couple of clicks, and now my database has the necessary indexes to provide great performance to my customers. There are some other types of recommendations in Database Advisor as well, but the principle is exactly the same. Now I want to go back to the deck. And I want to show you how some of our customers are using these features. So this is Christoph. He's the head of R&D for DocuWare, which is a German-based company that builds document lifecycle management software. DocuWare has chosen Azure SQL Database as a backend for their SaaS product, and they have many, many databases with us. So they're leveraging Database Advisor to help them proactively tune the performance of their databases, and they're also using automatic tuning to make their life easier and to make their customers happier. So that was about the performance. Now, let's talk about optimizing your costs. I know this is not exactly a favorite subject and topic for most of the developers. We all like to be techie and spend time coding, but to make a great business out of great database applications, we need to be aware of our costs, keep them to the minimum, so we can effectively compete in the market. So there's two main segments, two main areas of cost optimization within Azure SQL Database. One is you need to be able to select the right database SKU for your application. There's many SKUs to choose from. Finding what the right SKU for your application is not always easy. In addition, if your customers and your application have unpredictable load, peak and valley usage patterns, bursty behavior, then provisioning the right SKU is even harder because typically you'll need to provision for peaks, which is not very cost effective. And what happens when we get to the range of hundreds or thousands of databases? Provisioning each one of those for peak capacity will probably ruin your business plan. So there has to be a better solution. The other side of the equation is once you have the optimal SKU layout, that is, how do I optimize my application access patterns? How do I make sure that I'm accessing the data effectively? The first question I'm asking myself there is, how are my resources being spent? What is using the database resources I'm paying for? Which workflows in my app, which queries are the dominant resource users? And the key part here is the information Azure SQL Database provides allows you to go back and tune your application. So we go from query performance to application performance and making it work great for your customers. So on the application SKU choice part, Elastic Database Pools are a huge differentiator and a unique feature of Azure SQL Database. Essentially, it's a shared pool of resources where you can put more than one database or many databases, allowing them to actually have effective resource utilization and share resources if, as is the case for most of the database applications out there, not every database is constantly active all of the time. So this really helps with effective resource utilization for peak and valley and unpredictable usage patterns. What you can do is, one, cap your spending. So I can choose exactly how much resources I want to devote or how much I want to pay for a certain set of databases. Your bill never gets larger than that. And then databases within that pool would share resources with each other and then provide optimum and maximize the utilization, maximize the return on your investment. You're going to get your money's worth. And in addition, you can gain customer isolation because, as you can see at the bottom of the picture, you can set the per database minimum and maximum resource spending within the pool. So I can have a pool of 8,000 DTUs, which are the resource units of Azure SQL Database, and I can set exactly how much DTUs can each one of the databases use. So I can make sure that no database peaks, say, more than 10% of all available resources at any time. In addition to effective and efficient resource management, Elastic Pools provide much easier management at scale. They allow me to analyze and manage my databases within the pool using just a single command instead of doing some changes or some tuning for each of the databases. Now, how do you know you need a pool? How big of a pool you need? And which databases should go in the pool? You could do this analysis yourself, but there's no reason for you to spend your time doing so, because we have a built-in advisor that will do this for you. Essentially, what happens under the hood is we're going to look at all databases in your server and figure out which one of those are suitable to go in the pool and how big of a pool you need so you can maximize your resource savings and minimize your bill. Now we're going to go back to optimizing your application. So now that we have a perfect set of SKUs tuned for optimal costs, we still need to make sure that our application access patterns are optimal. So as per this diagram, we have a set of capabilities that will monitor your query patterns and profile them and understand which of these queries are using the most resources, making that information available at your fingertips in the Azure portal. So again, our friend Joe, the developer, can just log to the portal, open up and see the resource utilization profile for his application, making it easy for him to improve the app. Some of the views provided are top queries by resource utilization, by duration, or by frequency of execution. And as you can see, these are the things, duration and frequency, that our application users care for. It's not just about the resources, it's also about the experience. This allows Joe to easily find the bad query. And this is all based on query store data. Query store is a new feature of SQL Server 16 and Azure SQL Database that is essentially a flight data recorder for your database, records all of the data about query performance, stores them within your DB proactively so you have it when you need it. A typical analysis or troubleshooting session would involve, on SQL Server 16, okay, I need to do an analysis, turn on Profiler, wait for a week, come back, do it. No. The data is already there, collected and analyzed for you, and insights are provided so you can benefit from them quickly. We're going to go back to the portal and explore this. One sec. So first off, I want to show you the Elastic Pool recommendations. So this is my server. It has 24 databases under it, and including our CRM database. And as you can see, each of these databases is a standard S3 pricing tier, which means that it has 100 DTUs allocated to it. 24 by 100, this is a lot of money. Now the system, again, provides a recommendation for me based on my usage. Clicking here, I can see that, I want to zoom this for you a bit. Right. I can see that based on the current databases within my server, we recommend creating a standard Elastic pool, moving all 24 databases into it, and when they're all together, combined, they're gonna only need 400 VTUs instead of 2,400. And that'll give you monthly savings of 2.7K. This looks really interesting. I should probably take a look. One click, and I'm presented with the configuration of my Elastic pool. What the system is telling me that it's a standard pool of 400 eVTUs with 24 databases. And it's gonna cost me $900 a month instead of $3,600. Clicking on Configure opens up this pretty busy screen that actually tells me why the system thinks this pool is optimal for me. On the left-hand side, there's a combined resource utilization for all of my databases. And it typically goes around 100 VTUs, peaking above 200. With that in mind, system recommends a pool of 400. Over here, there's one bar for each of the databases within a pool, and they're sorted by their individual resource utilization. Blue line touching the maximum VTU for that database, and the green line showing the average. So it looks like I have 3 or so databases with larger usage, and then most of the others have large maximums but low averages, making them ideal for putting in pool together and allowing me exquisite savings. So I'll go on and create this pool. But before that, I can also customize the list of databases. So I can, for example, drop a couple. Let's drop the largest one, DB17, or this one. And the beautiful part about this is the recommendation is adjusted automatically. Now I'm not peaking at 230 VTUs. So this allows you to actually play with the configuration of your pool in real time. And again, as you change the config, recommendation follows. So this is about the pools. It's extremely easy and simple to set up an optimal pool for your server and save a lot of money. Now, we're going to open up our CRM database and see the other side of the cost optimization, which is the resources. I'm going to go and open up the Query Performance Insight feature. Here we are. And again, it presents me with top 5 queries in my application, which are the bars on the graph, each color indicating one of the queries. And this red line is the overall resource utilization for my application. So in this example, the top 5 queries are actually contributing to most of my resource utilization. I'd say eyeballing this more than 95%. And there's just one query, this yellow guy over here, query 151, which is responsible for more than 50% of resources used. So we should probably take a look. Clicking here, and this is, by the way, a second click, I can see exactly what this query is and what is its performance profile over time, making it really easy for me to just go on and probably improve my app. I can probably add an application side caching, optimize this flow a bit, and then save considerable amounts of resources. We've had some of our customers start their database, for example, in a premium tier, and then after several rounds of this tuning, cut their bill tenfold. So this is something that you should really, really take a look at. Going back to Query Performance Insight, as we've talked before, you also have a breakdown of long-running queries. So again, query number 151, the yellow guy, is the longest running as well. So it's probably worthwhile for me to have some of my devs take a look at this and see if they can tune this. Again, I didn't have to do any T-SQL. This is all pre-made, analyzed, and served to me on the Azure portal, making it really easy to benefit from. Okay, we're going to flip back to the deck. And it's not just PowerPoint. We have customers who use this and are really happy with this. And let me introduce you to our friend Morten. He's the tech lead of Umbraco. It's a Danish company that does CMS solutions for websites. And they have hundreds of thousands of websites that they provide CMS services for. Their latest product, Umbraco as a Service, leverages Azure SQL Database as the backend and leverages everything Elastic Pools have to offer to allow them to get easy performance, management at scale, at a super favorable price point, allowing them to compete effectively in the market. So that was all about performance and costs. I'd like now to hand it over to Ron to tell you about security intelligence features.
Thank you, Vladimir. So we optimize our performance. We control our expenses. Now let's secure our data in the CRM application. In this part of the session, I would like to show you how Azure SQL Database helps you to secure your data within minutes and without need to be an expert in security, using SQL security recommendation and using SQL threat detection. Public reports indicate there is a growing in frequency and severity of cyber attacks and internal threats on database, on organization nowadays. According to the latest report from Verizon, no organization is immune to cyber attack. And basically, in most of the cases, according to this report, there is a data breach of high sensitive data for the organization, which involve huge financial impact on those organizations. Since majority of the sensitive data is being stored in databases, it means that database security requires developer attention. Developers and organizations are doing whatever they can in order to secure their data, trying to meet the high security standards recommended by auditing authorities, building up monitor solutions that will enable them to track those threats. But in many of these cases, unfortunately, developers and organizations have limited security knowledge, limited time, and limited method in order to secure their data. And unfortunately, even the most common attacks on databases, such as SQL injection or malicious insider, which are breaching data from your database. So the first SQL security intelligence feature I would like to share with you is SQL security recommendation within Azure Security Center. Azure Security Center, it's a new service in Azure which allows you to understand and improve the security health of your Azure resources. One of the first or most common requirements from auditing authorities is to make sure that the data is encrypted while the data resides on the disk, on the physical storage. In addition, you need to be compliant. In order to be compliant, you need to set up auditing to make sure that on every minute you know who did what and when for your database. And one of the nice things you have using Azure Security Center, which is a built-in service in Azure, it's automatically identify databases and servers which didn't enable auditing or encryption at rest. And it's provide you actionable recommendation, so within few clicks, you will be able to enable this and meet those audit requirements. The second security intelligence feature I would like to show is the SQL recommendation as part of Azure SQL Dynamic Data Masking. Azure SQL Dynamic Data Masking, it's a built-in feature in Azure SQL Database, which allows you to limit the exposure of sensitive data within your application by masking the sensitive data in the query results. Dynamic data masking, SQL Dynamic Data Masking, automatically discover sensitive data within your database according to its schema and provide you actionable recommendation, so you will be able within few clicks to apply this recommendation and secure this sensitive data. So it will be masked when the application or developer that are approaching the database will not be able to see this sensitive data in clear text, only on a mask format. And the good news is with this dynamic data masking, you will not be required to change your application at all. So let's see it's in action, the SQL recommendation in action. OK, so I will start by navigating to the Azure portal.
1 second.
OK, thank you. I will start by navigating to the Azure portal. This is Azure Security Center. It's an option that you can navigate from the main menu. And as I mentioned, Azure Security Center allows you to understand and track the health of your different Azure resources. So the top area includes the recommendation that will allow you to take preventive action and secure your different resources in Azure. And the bottom line includes your security incident. So if there is a potential threat on one of your resources, you will be able to view it from here. So let's dive into the data category. This includes all the Azure resources that store data, such as SQL database and storage. As you can see, on the top of the blade here, you can see there is a clear summary of which database didn't enable auditing on the database on the server level and on the database level, or didn't enable encryption at rest. You can also see I have one healthy database. So for this demo, I selected the sample CRM. This is the database that I use as the backend of my CRM application. And you can see that there is also a nice tree that shows you the breakdown of your health status for your databases within this tree. So you can see that for this database, auditing is disabled and encryption at rest is disabled. So now let's follow this recommendation. So when I click on this node, it's opened 2 recommendations that will allow me to take preventive actions and enable auditing, threat detection, and enable encryption at rest. So I will pick the first one. And the nice thing about it is that it will take me to the relevant blade on the SQL database that will allow me to enable auditing and threat detection. So I will switch on this simple toggle. I will select the storage. The audit log in SQL, Azure SQL Database is being stored, on a storage account that you own. So I will select the storage. In addition, one of the nice things that we offer, which I will elaborate later on, is the threat detection. So I will also enable the threat detection, which will allow me to get security alerts if something went wrong from the security perspective. And I will also set up my email account, so I will be able to get notification if something went wrong. I will save it. That's it. My database is now secure, is audited. I have also a threat detection layer, which helps me to protect it. So now let's move to the next recommendation. So the next recommendation is to enable encryption at rest. As I mentioned, both of these, auditing and encryption at rest, are mandatory requirements for most auditing authorities. So I will click on it. And again, it will take me to the relevant area in the Azure portal, which allow me to, within one click, to enable encryption at rest. So I will save it. As you can see, as we speak, the data is being encrypted on the back end. And again, finished, that's it. Now my database is encrypted at rest. I have auditing and threat detection. We are good to go. Now, the other type of recommendation that I explained before is the dynamic data masking. So in order to enable or use dynamic data masking, I will go to the database blade. By the way, you can also enable auditing and threat detection and transparent data encryption from the database blade, setting blade. But this time, I will go for dynamic data masking. So as you can see, I do not have any recommendation applied for this database. And automatically, Azure SQL Database detects that I have potential sensitive data on this database. So you can see that I have this customer, let's see the first name, maybe let's mask the phone number and email address. This is clearly a private information, and I will save it. That's it. You know what? Let's make it even more interesting. Sometimes in the application, we want to expose part of the data, so a partial part of the data. So for the phone number, it's very useful sometimes to see the last 4 digits of the number. So I will open this masking rule, and I will change it to partial. And I will decide to expose the last 4 digits of the phone number. Save it. Okay, and save it, and that's it. So Azure SQL Database helped me to find this sensitive data and mask it. Now let's see how it's worked from the application side. I promise no changes for your application, right? So now this is before I set the masking rule, so I will refresh it. You can see the email and the phone number are in clear text. I will now need to log on again. Voila. My email and phone number are masked. Again, I don't need to care about it. Maybe there is this email and phone number appear in several pages in the application. Once you set down the data masking on the database level, so you are OK from the application side, because the database does the work for you. OK, so getting back to the presentation. So let me share you a feedback for one of our customers that already benefit from this SQL recommendation feature. So this is France. France is our CTO of New Orbit. It's a customer in the UK that provide cloud-based solution for enterprises and financial organizations. Naturally, a lot of enterprises and financial organizations have sensitive data, and France customers are concerned specifically, and they ask him to make sure that his database and the rest of the solution are compliant. And as you can see, France finds it very useful. He has a lot of projects, a lot of database, so we use it on a daily basis, the SQL intelligent recommendation, to make sure that he enable auditing, to make sure that he enable encryption trace, to make sure that he secure his data. And this saves him a lot of time. So the last security intelligence feature and the last intelligent feature that we will present here is SQL threat detection. SQL threat detection is another built-in feature as part of Azure SQL Database that helps you to detect anomalous activities, indicating a potential threat to your database. It's super simple to enable. You saw it on the demo. I simply enabled it on the auditing blade. And I can also use the Silent API in order to enable that. And it requires no changes to your application. Once you set it up, you already have a set of world-class algorithm that works for you around the clock to learn and profile your application behavior and detect anomalous activities, indicating possible malicious intent to access or breach or exploit your data. For example, it includes an ability to detect potential SQL injection vulnerabilities or SQL injection attacks. In addition, it allows you to access anomalous activities, such as someone is accessing your database from an unusual location. And once the SQL threat detection detects these suspicious activities, automatically it fires a security alert over the email that you just saw, and also to the Azure Security Center. And within this alert, you will get a set of recommended action that will allow you within one click to investigate or remediate the threats and prevent a possible damage as a part of these threats. So let's see how threat detection works in action. So you remember our CRM application. Now it's secure, it's optimized, but let's see how it reacts to cyber attacks. So I will log out for this application. To be honest, I didn't do a very good job in this CRM application. I use a very naive authentication. So I just have some kind of a user table, and I select it when I want to pass the authentication. So I would like to bypass and try to bypass this authentication phase with a simple SQL injection technique, adding a true statement. It doesn't even important what password I will use. As you can see, I was able to bypass authentication. Unfortunately, this kind of error exists always. People are developing their application, adding new logic, and they forgot to properly validate the content, the user content, which makes them vulnerable for SQL injection, and which means, and usually the web is the most common attack surface, which means the data on the database is vulnerable. So you remember I set up SQL threat detection. Now let's go to my inbox. As you can see, I got an email notification that there is a potential SQL injection on my database. So it's include a clear explanation. It provide me the relevant details on these threats, subscription, database name, user. It also provide me a good guidelines that's how to write my code properly with a code example. But most useful is this action. It's allow me to view the SQL statement. So I will click on that. Automatically, it's open the Azure portal. You probably know Azure logs include a lot of audit record. Where should I go? There is a potential attack. So what we did and what we offer in Azure SQL Database, we save you time on this part as well. So we like opening you the relevant audit record, which was include this potential SQL injection, and we even do more than that. We even highlight the relevant audit record. This is all the events around the time. This is all the audit records around the time of the event, and this is the vulnerable event that include the relevant statement. So I will click on that. As you can see, it's included clear information about the audit records, and most important for me as an application developer, it includes the SQL statement. And I can track this SQL statement and see which code generate this SQL statement, fix it, and avoid further damage to my database. So back to the deck. So now I would like to share with you last two typical customer testimonials using threat detection in the last few months. So this is Mr. Logan. Mr. Logan is a tech lead. He's an architect and tech lead in a company that runs cloud solution for a health professional, mental health professional. You can understand from the type of users that this database has a lot of sensitive data, health data, sales data. Mr. Logan enabled threat detection a few months ago, and after a while, he got a notification. Someone has accessed your database from a new location. So naturally, he was worried and started following the alert and find out that one of his developers has accessed the database from his home, a production database from home. As a result, now Azure SQL Database and threat detection became an important part of their incident response plan. And customers and developers are more aware that everything they are doing is being tracked, and it's helped them a lot. And usually before that, he was not aware that these activities happen on his database. Last story that I want to share with you is another customer. This is Mr. Richard Priest. He is the head of technology for Missing Widget. He's also using Azure SQL Database as his primary storage. He enabled threat detection about a month or so ago, and started getting notification from threat detection that his application is vulnerable for SQL injection. He got several alerts. He was able to do exactly what I did in the demo, to track down the vulnerabilities and attacks and fix his application, also reading the guidelines. And thanks to that, he was able basically to prevent SQL injection attack. That's it. So back to Vladimir.
OK, so we'll now show you and demo to you the security, performance, and cost-saving intelligent features in Azure SQL Database. So the next obvious question is, can I benefit from it? Can my application use this? And the answer is yes. Everybody can benefit. And when we say it, we really mean it. So we've shown you how easy this is to use from Azure Portal. But Azure Portal may not be convenient for you. You may have a portal of your own, or you would like to access this via the APIs. And then Azure REST APIs allow you to do just that, and some of our customers are effectively leveraging those to consume the tuning recommendations and actionable recommendations and automatic tuning via the REST API. In addition, there's the DevOps favorite mode of interacting and automating maintenance actions, the PowerShell. And this makes a standard set of Azure APIs. So whatever is the most convenient way to use it, you can. In addition, as Ron has shown you, the security officers may prefer to view all the security recommendations from all of Azure resources from one place. So we've integrated all this into Azure Security Center. And finally, you can access this through Azure Application Insights as well. So whatever is your most preferred or way or ways of accessing these recommendations, you can do that. And now finally, we have another myth to bust, which is, hey, my app is not a Microsoft stack. This all sounds nice, it looks good, but it's not for me. You'd be wrong. Azure SQL Database comes with a full set of drivers for all of the most popular languages and frameworks out there, starting with the Microsoft stack, but also including Java, Ruby, PHP, Node.js. From the frameworks, we obviously support Entity Framework, but also Hibernate, Rails, Django. Anything and everything you have can actually leverage this. So you can move your database backend into Azure SQL DB, and your application can benefit from the built-in intelligent insights immediately. So finally, we want to recap this and go over the key points, which is the built-in intelligence works round the clock for you, helps you configure, optimize, and tune your database within minutes without requiring you to be the expert. We've seen how in performance, the SQL Database Advisor provides actionable recommendations and automatic tuning to help you speed up your application and prevent performance incidents. We've seen how Elastic Pools and Query Insights help you configure your database queues in an optimal way, even for one database or for thousands of databases. And we've seen how Query Insights help you understand the resource bottlenecks in your application and tune those. And lastly, the intelligent security features help you secure your data and detect and prevent attacks and threats against your database. You've seen how easy and simple this is to use. Each of the demos only took a couple of clicks and very little effort from your part. So you can have the most advanced tuning algorithms, which are being improved every day, be put to good use and help you and your application and your customers get the most out of Azure SQL Database. In addition, I think probably the most important point is you don't need to change your application. And this is available anywhere and everywhere. This is not Microsoft-only story. Azure is open for everybody to benefit from. And Azure SQL Database aligns with that from ground up. We've also shown you how some of these companies, global companies, are benefiting from this today, allowing them to cut on time required to manage and tune the databases and allowing them to spend their time and energy building great applications, making a difference to their business. This is extremely important since while most of this may look and feel and smell like future, it's actually there today. And you can go and move your database backends into Azure SQL Database and benefit from this instantly. You may also wonder, why now? Why is now the right time to do this? It's the power of the cloud, essentially enabling us to understand the usage patterns, analyze them at scale, hone and sharpen our tuning algorithms to the point where we can provide deeply customized and tailored experience for each and every database. So the way to think of this is you can get a virtual DBA, somebody who will do all of the heavy lifting 24/7, round the clock, so you can devote your time and energy where it matters the most, building great applications. That's all we had for you today. Thank you, and we'd like to open up for questions.